and welcome to this 16th lecture of our course blockchain and its applications. Also it is the 4th lecture on the topic of blockchain elements. The particular concepts that we will cover in today's lecture are as follows. We will see how to join a Bitcoin network. That means that any node, if you remember that Bitcoin or for that matter any blockchain is essentially a network of peer to peer nodes. And when we say peer to peer, it means that there is no central controller, not a centralized server that you have to take permission from to join that peer to peer network. So, any node can join the network, and by any I mean exactly like anyone from the public, you, me, all of us can join that. So, we will see how to join a Bitcoin network. We will also see that as different users are carrying out transactions, and we have studied what these transactions mean in our last lecture, and when these transactions are created in any one particular node by one user, how these transactions are propagated to the other nodes of the network. Then we will see that when the blocks are mined, and we understand what is meant by mining of blocks from our previous lectures, and when a block is mined, how that mined block is propagated also across the entire network. So, that is what we will talk about in terms of propagation of blocks, and then we will see that in case there are multiple such different nodes which generate a new block, how we can determine which of that will eventually be staying in the blockchain. So, these are the concepts that we plan to cover in our today's lecture. Also the keywords are as follows: the Bitcoin nodes, as we mentioned, what is a Bitcoin node, that is important. What is meant by transaction flooding, we will see that. Block reward, we will take some examples of that, and then block propagation, and finally fork in blockchain. So, we will start our discussion with what is a Bitcoin P2P network, that is peer to peer network, as we have mentioned before. So, it is as mentioned here, it is an ad hoc network, that means there is no fixed topology of it specified or determined a priori. It has got a random topology and it runs over the TCP protocol. So, all nodes, that is the users in the Bitcoin network, are treated equally. So, that is important, that there is no centralized server, no client server kind of architecture. We also do not have anything like a master slave kind of architecture. So, all nodes in the Bitcoin network are treated equally. So, new nodes can join any time. As I said, any node can participate in the network at any point of time. So, this is very important, that new nodes can join any time. So, there is no fixed time that only this is the window in which you can join, and the nodes that are not responding, they are removed after some time. So, there are no such spurious nodes which are not responding to the entire network. So, these are removed after a period of inactivity which is typically 3 hours. So, let us see that how this joining of a node in a Bitcoin P2P network actually works. Say this is the current topology of the Bitcoin network. So, as we can see that there are 8 nodes, and let us assume that it is your node, you are creating a node to join the Bitcoin network. So, when I say your node means you have a system and you can download its this installation script for Bitcoin. You can simply execute that script in your machine, and then that will serve as a node of this Bitcoin peer to peer network. So, let this red circle be this node which is your node, where you have installed the script for Bitcoin, and then what should be the first thing. So, currently it is just a machine which is connected to the internet, and you have downloaded the script for Bitcoin, you have executed the script, things have been installed, and then of course, now it has to be a part of the existing P2P network. So, currently there are 8 nodes which were there, and then this 9th node which is your node has now been started, and this node wants to join the network. So, what it will do is that it will first have a seed node to which it will ask that give me an address for joining this particular network. And when this seed node gets this request from the new node, what it will do is that it will send the address list. Okay. And this address list also would mean that in P2P network and specifically also in the Bitcoin network, what happens is that this node, each node will typically be communicating with a number of its peers, okay, its neighbors or friends, whatever you call. It is not going to send every information to every node in this network, because there are so many nodes in the network and it is not practical or it is not feasible to send all information from every node to all other nodes. Instead, what is done is that every node will have a set of its peers, its neighbors we can call, to which they will be sending their information, and then they will be sharing with their neighbors and then the neighbors and so on, and in this manner, as we will see, that the entire network will get all pieces of information. So, this node gets the address list for its neighbors from the seed node. So, that is the very first step, and then this node knows that, see, these are my neighbors. So, as you see that this particular node, this new node is now connected to 3 other nodes. So, for this new node, its neighborhood is basically these 3 nodes, which are this one and this one. And likewise, if you see, if I consider say this as my node, it has got again this one and this one as its neighbors and so on. So, you see that every node is connected to a set of other nodes and not to all the other nodes. Okay. So, that is how we get each new node connected to the network, and it is now available in the network, and it also knows which other nodes are its neighbors. And then what happens, that suppose you have installed the Bitcoin software, and then now if you see that Bitcoin is a collection or a chain of a lot of blocks, starting from the very first block, block number 0 to today's the latest one. So, what it will need is that it will need to get the most recent blockchain. So, what it will do is that it will ask its neighbors and it will get the most recent blockchain, and once it gets the most recent blockchain, now it is at par with all the nodes, all the existing nodes, the thousands of existing nodes in the Bitcoin network. So, now this red node, which is the new node, maybe your node, that is now one of the valid nodes in the Bitcoin network. That it is that simple, and you can actually try it out yourself also. Remember that, as we mentioned, that if this becomes non-responsive for certain period of time, then it will be again removed from the node, and then it will follow the same process to join back in the network. So, once this node is in the network, it can carry out transactions. Remember that if you join this Bitcoin network by setting up your node, as we mentioned, it is not necessary that you have to carry out the transactions. So, you could just be there and you could keep checking what all transactions are going on in the network, which are new blocks that are getting mined, and then which transactions are going into that, and what are the inputs and outputs of those transactions, as we have studied before. Of course, you will not know who those people are who are carrying out the transactions. And then your node will behave exactly the same way that we have seen, that when you went to btc.com, we saw that a list of different blocks that are getting added, and we could actually click on those blocks to get the list of transactions. We could click on those transactions to see how much of Bitcoin was being transferred and so on. So, exactly the same thing you can also do it in your node once you have joined the network. But if you are interested in carrying out a transaction, then now you can start your transaction, but it is not necessary that you will always have to carry out the transaction. So, if this new node wants to start a transaction, say now Alice wants to start a transaction, and assume that it was indeed Alice, this red new node, and then Alice has been now all set in this Bitcoin peer to peer network, and then Alice wants to carry out the transaction. So, Alice has joined the network by opening her applet. So, there are these applets that you can actually click and open and it works, and then Alice makes a transaction to Bob, which is Alice to Bob of BTC 10. So, let us for the time being, let us not worry how Alice got enough bitcoins to transfer. Suppose Alice had got it and then she left and then rejoined the network, and then her bitcoins are still available, and from that she is now making the transaction of 10 bitcoins to Bob. So, if you remember that Alice has to include the scripts, the script pub key in her transactions, and then it has to be sent to all the nodes in the Bitcoin network. So, that is the requirement. So, how does that happen? So, let us see this, that now this is Alice, as we said it was you. So, it could be you, imagine yourself in place of Alice, and then you are now carrying out this transaction of transferring this many number of bitcoins, which is BTC 10 to Bob. So, what Alice would do is that Alice would be sending this transaction to her neighbors. So, you see that Alice had 3 neighbors, and Alice is sending this transaction which we denote as A to B, then BTC 10, and then Alice has sent this transaction to all her neighbors. If you see the title of the slides, it says transaction flooding in a Bitcoin network, but it does not mean that Alice is indeed going to flood the entire network with her transactions, but as we will see very quickly that her neighbors will now be sending it to their neighbors, and then those neighbors, the neighbors of neighbors will be sending to their neighbors, and so on. So, that is how actually the flooding will take place. It is not Alice who is flooding the entire network. So, every such node who gets Alice's transaction will validate the transaction. So, that means that they will check based on the script SIG that Alice had provided, whether indeed it is a valid transaction, that everything is in place, Alice has signed it, and it has been proved that indeed Alice had got those bitcoins which she is now spending for these out of those bitcoins she had 10 bitcoins she is spending to Bob. So, all these validations will be done by these nodes which have got it from Alice, and once it is validated, what they will do is that each of such nodes will now send it to their neighbors, as I mentioned. Now, this green node out here which got it directly from Alice will be sending it to all its neighbors. So, we see there are 4 neighbors of this node. So, it goes to all of these different nodes. But of course, you can understand that this also means that this particular node which is at the top, that was actually the one which got directly also from Alice. Okay. And now, it is also getting it from this particular node. Then what happens? That means that this node is getting the transaction first from Alice, then from one of our neighbors, which is also a common neighbor for this particular node. So, what it will do is that it will see that this particular transaction it has already seen before, and because it has seen before, so then it is not going to add it to its list of such transactions. So, it is not a new transaction for this particular node. Okay. So, it knows that if it has already sent the same transaction previously received directly from Alice to its neighbors, then it will not once again try to send this one which it got from one of the neighbors of Alice, which was a common neighbor for this one, which indeed is this particular node as is mentioned here. Okay. So, that is fairly simple, otherwise there will be so many such duplicate transactions which are going on and moving around in the entire network, and it will be flooded. So, that is how they ensure that only they are going to send this particular transaction once and not every time that it gets it. So, which transactions should you relay? So, this is like relaying those transactions that they are receiving. The transaction should be valid in the current blockchain, there is no conflict, and also there is no double spending. So, we will see a bit of more detail about double spending. It means that if Alice has got say 10 bitcoins and Alice is sending those 10 bitcoins to Bob, and then before that particular transaction gets added to the blockchain, Alice again spends the same 10 bitcoins on Carol. So, that means Alice had 10 bitcoins to start with, and she is spending 10 first on Bob, again another 10 on Carol. So, which is not something that should be allowed, which is called double spending. So, these kinds of checks are done before these transactions are relayed. and the script of course has to match with a pre-given set of whitelist scripts. So, we have studied these scripts and we have seen variations of that. So, it will check for some unusual scripts, there are no sort of possibility of infinite loops which will cause difficulties. So, if there is no such conflict and all, then only what it will do is that it will now relay the script to the other nodes. So, in this way what we see is that every node is getting copies of every transaction. So, it might be possible that at some point of time some of these nodes have got one of those transactions, but not some of the others, and which is quite obvious because these are all happening in asynchronous manner and there is no centralized control. So, if you see that at this point of time Alice has got these 2 transactions and this particular node has got only one and some of them has got the second one, and also you see that in Alice we have the first transaction here, and also in this node we have that A to B BTC 10 is the first transaction and C to D BTC 20 is the second transaction, while in this case if you notice that there is this difference, that it has got first the C to D BTC 20 and then A to B BTC 10. So, they can come in any particular order and we do not want to control that. So, different nodes may have different transactions pools at any point of time, and then they accept the transactions that they have heard. So, they might have just got the first transaction is A to B BTC 10 and they have checked it, it is validated, nothing wrong. So, it will accept that it is a valid transaction which has been received by it. So far we are talking about getting the transactions from various other sources, and they might themselves also originate those transactions like we have seen in the case of Alice. So, now having said that, we now have got every node in its, we can call it cache, a collection of transactions, and these transactions have come after the last block has been generated or mined. So, these terms of blocks generated or blocks mined, we will be using them interchangeably. So, what has happened? We have got this last block, say that was block number say 100,000, and now we are accumulating certain new transactions in each of these nodes. So, then what we need to see is that how finally these will be created into a block. So, what will be done is that now after some time the first set of transactions that you have heard, then you decide that I will create a new block out of the transactions that I have so far heard since the last block was generated. So, that is the status in each of these nodes, and we are just giving some examples of maybe 2 or 1 such transaction since the last block, but typically that will accumulate certain, of course, more number of transactions. We have seen that the size of the node should be about 1 megabyte, and then if each transaction is of say a few kilobytes, then you will have only say a few thousand number of transactions in every block. So, that is the whole idea. So, at this stage what has happened? The nodes know that I have got this new set of transactions, and which we have to now start mining, meaning that now have to mine or create a new block, that will be block number 100,001. So, the last block was 100,000, say some new say 200 transactions have been accumulated in a node. Remember, when I say 200 transactions have been accumulated in a node, it does not mean that each node has the same set of 200 transactions. They can have many different orders, and some of them may have 200 transactions, some of them might have 300 transactions, some of them might have 1000 transactions. As long as these nodes find that they could make a block out of the transactions they have received individually, and the size of the block is not going to exceed the maximum limit of 1 megabyte, they can decide to create a new block out of the transactions they have received. Okay. So, as you can see that some of these nodes we have identified with the icon of a miner. So, that means that not all nodes are doing the job of mining, and if you remember that we said that with you joining the network you could see all these transactions, all the new blocks, but you may not have sufficient hardware to do the mining. So, you did not do the mining, as we see that not all the nodes are doing the mining, and as we mentioned before that it could be some nodes which pull together their resources and do the mining because they have lot more computation power, and why that is important we will see immediately after 1 or 2 slides. So, each of these mining nodes, what they do is that they will collect and they start mining. The mining is the process of including a set of transactions, and then from there including means, if you remember, that means creating the Merkle tree out of those transactions, and then once those are there, you have to get the root hash of the Merkle tree. And if you remember, there are other 5 components including the nonce, the timestamp, the version, the previous hash, the difficulty bit. So, that nonce is what they have to figure out by spending lot of computational effort, and then based on difficulty bit they know how many leading zeros would be there, and then they search randomly for the nonce and they end up getting a particular nonce that satisfies the required number of minimum leading zeros. And once that is done, then that 100,001 number of block will get mined, and mind it, all of these miners are trying together to generate these blocks. Okay? So, we have to keep that in mind. So, the miner that solves the puzzle first will generate the new block, and we see here this one is the miner who could actually generate this new block. So, that block number 100,001 got generated by this particular miner. Again, remember that all of these miners were working on their set of transactions, and which might not have been exactly the same in all these 3 miners nodes. So, keep that in mind, and that is not important for working of this Bitcoin network. So, whatever it is, this particular node will now be able to add this new block, that is block number 100,001, to the existing blockchain, which so far had 100,000 blocks. Also, what happens is that for generating this block, the miner will get some reward, and that reward will go only to this miner which is able to add the new block to the blockchain, because this miner was the first one to solve the puzzle and come up with this new block, which is block number 100,001, and whatever effort was spent by these 2 other miners, that will go waste in terms of computational power, whatever they have spent, or maybe paying for their electricity and all. So, they are not going to get any reward. So, all these 2 had unnecessarily spent their effort and their money to try to get the new block, but they failed. But maybe they will do it for the next one, they might be able to mine the next one and get the reward and so on. So, now what has happened is that now that this particular block has been able to generate, this particular node has been able to generate the new block. So, this miner has won. So, this miner gets the reward, and then now this miner will be flooding the blocks. Previously, we talked about flooding the transactions. Now, this miner will flood these blocks, this new block which has been added to the blockchain, and now it sends it to its peers, and then they will be now adding it to their peers and so on. But before they add, they will ensure that they check whether the block has been generated correctly, the hash of this new block is matching with the required number of leading zeros, and that is the step that we had checked through one of the sites, how to check whether the hash of the block indeed is correct. So, based on the difficulty bits and those 6 different components for calculating the hash, if you remember, we did that small exercise on one of the websites that support checking of these hash block hashes, and there are other sites as well. So, they will check it and then they will add it to the existing blockchain. So, if you remember, when you had joined with that red node as you shown, you had say 100,000 blocks in the Bitcoin network, and now say if it was you, if you remember, suppose it was you. So, then you did not do the mining process, and you got this new block from this miner who has won, and then what you do is that you will check it, as you can see that this indeed has a correct hash, and then you will add it to your own blockchain, your version of the blockchain, and then you will be flooding it to your neighbors, and they will be sending it. And again, so if they get it from 2 sources, they know that they have already been able to add one, so they will not do it again. Also remember that what happened to all the other miner nodes? Say they were trying to mine also the transactions, but they could not do it first. So, this miner has won, and now those miners who had also given the effort, like say this one, when it gets this new block added, because till it gets the new block, it does not know indeed the new block has been mined. So, when it has been mined and it has been sent to it by its neighbors, what it will do is that now it will give up trying to get that 100,001 number of the block. Instead, what it will do is that it had this list of transactions which are not yet included in any block. As I said, maybe it was in their cache, or so let us call it as cache. So, what it will do is that all the transactions that have been included in this block, this new block which is mined by some other miner, it will remove it from its cache, and then it will be left with the other transactions, and in the meantime also new transactions will get generated. So, what it will do is that it will again try to accumulate a certain number of transactions and generate a new block out of it. So, that is how things will be proceeding. So, now what we do is that we see that how this mining of new block is happening and how it is getting added to the network one by one, and this is how the block gets propagated. So, multiple miners can mine a new block simultaneously or in a near identical time, which might result in what is called generation of a fork. But before we go to the generation of the fork, what we need to understand now is that we have got the new block added to the blockchain network. Every node is now aware of it, and they checked that indeed it was a correct block that got added, and that checking for whether the block hash was correctly generated was fairly simple, as we have seen. In a matter of like fraction of a second it can be done, and they are happy with it, and then they again start spending effort on mining the next block. Now, there are these two pieces of reward that a mining or a miner node gets when they successfully mine the new block to be added to the network. So, why are these three mining nodes or these miners spending their effort and money on trying to get a new block added to the blockchain network, the Bitcoin network in this example? So, the reason is that for generating a new block, they get some block generation reward, some amount of Bitcoin. We will see how much that in our next lecture. Also, for every transaction, the users who had added those transactions also commit to paying a small amount in Bitcoins also to these miners who would finally successfully generate the new block to be added. So, if Alice is sending these 10 Bitcoins to Bob, in order to Bob get it, actually that transaction has to be included in a particular block, and then only Bob will be able to spend it. So, for that Alice would also commit that, oh, I will spend this much of Bitcoin or pay this much of Bitcoin to the miner who will be able to include my transaction in the block, in a new block. So, that is the reward for the miners. They get some block generation number of Bitcoins, and also for each transaction they get some amount of additional Bitcoins. But what can happen is that when several such miners are trying to generate the new block, it can be possible that after block 1, these two miners almost simultaneously generated, one generated block 2, another generated block 3, and some of the nodes got block 3 first, and they added the next one, which became the next block in the chain, which is shown here as block 6. But those who got block 2 as the next block after block 1, they might start adding block 5, and then you see as they are propagating, different nodes will be getting these different blocks from their neighbors, and they will get in certain order. So, based on maybe the majority of the neighbors who have sent them a particular block as the next block, they will treat that to be the current part of the next block in the blockchain. So, in this manner, because it is happening asynchronously, what will happen, one of these chains will become longest, and that is the one which will be accepted by the majority of the nodes, and eventually that will be the main chain of the network, this blockchain network, and these ones like which are shown here, these indeed will be dying out. So, this will not really be the final one. So, if we see that this one which continues and then maybe like this, and say it becomes further longer, then that will be the particular chain that will sustain, the rest will not further be used, and no new blocks will be added to those. So, there could be such accidental forks which can occur, but that occur very rarely, and once they only one of them will eventually become part of the longest chain, as is shown here. If block 2 and block 3 were were generated simultaneously causing a fork, but this block 2 finally remained in the longest chain. Hence, this will not be sustainable. And there are certain intentional forks are also created. So, accidental forks are very rare, and there are two types like hard forks and soft forks, which can be done to generate new versions of the network like Bitcoin Cash and so on, and for upgrading of the software version. So, most of the time these types of generation of the forks is not done accidentally but through some intentional means. So, the blocks that are correct hash, those have been relayed and all the transactions have been valid, and the block should be included in the current longest chain. So, that is basically the summary of how this block gets propagated, and only the longest chain prevails in a Bitcoin network. So, to conclude, we have shown how a new node can join the Bitcoin network in detail, the steps, the creation and propagation of first the transactions, accumulating of the transactions and mining of new blocks, and then we said how the new Bitcoin blocks get propagated in the entire network. And also we have discussed how forking is handled in a blockchain by only maintaining the longest chain, the rest will be dying out. And these are the references. I have added one more reference here from Springer. So, these are all fairly recent books, and you can also follow any other textbook on blockchain or Bitcoin for understanding these in more detail. So, with that we come to the end of today's lecture. Thank you very much for your attention.